What's up, fungal associates? Welcome to Completely Arbortrary, the podcast about trees and other related topics. My name is Alex Crowson, and of course, I'm here with host number dose.
Good day.
Good day.
Don't think anything further through that, Alex. That is just me saying good day with excitement.
Okay, so I shouldn't assume that we're about to venture on some sort of, I don't know, New Zealand and or Australian themed series of trees over the next few weeks?
Correct. Don't make that assumption.
Okay.
Well done. Well done. Okay.
Should I just wait for you to tell me instead of making that assumption?
No, I just I said it because I was excited, and then I realized that we're talking about a New Zealand tree.
Yes.
Not Australian. Australians are notable for their the classic good day.
Good day.
And so now I'm realizing that everyone's going to think, oh my gosh, Casey, you're an idiot. We're a different country. I know that it's a coincidence, and I'm trying to just shine a light on that.
I think it's possible that New Zealanders say good day. It could be.
I have never heard a single person in this entire world, other than one Australian, say it.
And
by
that
I mean,
Australian was
an Australian.
Was Crocodile Dundee.
It was the Crocodile Dundee. Yeah. So
That's not a knife.
Anyway, no, good day, Alex. Good morning.
Good morning, Casey.
I hope everything is going great.
Yeah, everything's all right.
Do you know there's a meteor shower right now?
I did not know that.
I didn't either until I looked it up. But you know, here in Oregon, we have clouds all the time, and the only time we see meteor showers are in like middle of August or July.
Okay, yeah, when there's no clouds.
Exactly, because
Yeah.
I just randomly saw that one was coming up, and I was like, oh, I wonder what it is, and it was like, it's peaking right now.
It's peeking.
Yeah, and I looked up, and I was like, it's impossible.
If only it were peeking through the clouds.
Yeah, right. Oh, wow.
All right, Casey. Well, today
Get out of here.
we're talking about a very interesting tree. In fact, we're talking about a tree the likes of which we have never, ever talked about.
No, we haven't even come close before.
This is our very first Podocarp.
Yes.
You would think on a podcast we'd be talking all about Podocarps, but this is our first one.
Yeah, and you know how much of a, how distressful that is to me?
That we haven't talked about Podocarps?
Yes.
Well, you put your distress aside, turn it into normal stress, because today we're finally getting into it. That's right. Today we're talking about the Totara.
Yes. Well done.
I had to stop myself from the other pronunciation.
Yeah. Now, I told you that I actually really wanted to do this tree when we did My Neighbor Totoro.
Right.
Because I thought it would be hilarious to have one that's called My Neighbor Totara.
Right.
And then realize that everyone was like, oh, I love that movie. And then we talk about a tree from a different volcanic island in the southern hemisphere that has nothing to do with a camphor tree or Shinto or anything like that.
Wow.
Kind of funny, you know, right?
Yeah. It would
think?
be, I think it would subvert expectations, which is in itself
Subvert
hilarity.
expectations. I love that. That's a great term.
You know, it's all about subverting expectations.
Yeah, I like the idea of subverting an expectation where you're just really undermining it.
Wait, what am I saying wrong?
I don't know. You're not saying anything wrong. It's just
Oh.
I don't think it's a common use of either one of those terms.
Oh, of course it is.
I don't think I've ever heard subvert expectations.
What is what do you usually hear? Is there a different term that you hear more?
I just don't think I've ever heard that.
Oh, well, subverting expectations is like, classic,
Espionage.
I can't believe you've never heard this term.
No, is that? I feel like there's another term that I can't think of that's very close. Like, remember a couple weeks ago you said superfluous when you actually meant
Superlative.
Yes.
Yeah.
That's what I'm thinking might be happening.
Well, Casey, we could spend all day trying to figure out what the hell each other is saying, but I think instead we should take a quick break because when we get back, we're getting into our first of a few New Zealand trees. However, before we take our break, I want to propose something.
Yes.
Since we were talking about New Zealand trees, I think the expectation is that you and I will bring up Lord of the Rings a lot because those films were shot in New Zealand, directed by a New Zealand filmmaker.
Yes.
However, we are going to subvert expectations and say every time you and I accidentally mention Lord of the Rings,
Okay.
we're going to put $1 in a jar.
Okay.
And at the end of the month, we'll buy ourselves a little treat.
A little llama's bread.
There's $1.
Oh, damn it.
What the fuck?
Sorry, dude. Sorry.
Actually, if I want a little treat, I should encourage us to talk about it.
Yeah, honestly.
That's the whole game,
You know what?
really.
Everyone else, if you at any point think about that movie series that has to do with those characters in that place, you have to send us $1.
Yes, please.
That's the rule, starting now.
Casey, you got to take a quick break.
Okay.
When we get back, we're talking Totara here on Completely Arbortrary. Welcome back. Casey has become tradition. Casey is removing his sweatshirt
It turns out that
to reveal a second sweatshirt.
I close the window behind me, and then it gets really hot.
Yeah, I've got the my normal. I know this is very bad for many reasons, but my go-to in the wintertime is to have the window open and the heat cranked.
Which is counter to how I think it should be done.
Well, that's fine. I do a lot of things counter. I subvert your expectations
You
constantly.
do subvert my expectations. Yeah, I knew that about you, and I didn't mean to comment. I actually specifically didn't because you made comments before where you like to have fresh air.
Yes,
but you also don't want to be cold.
Exactly. It makes perfect sense to me.
Yeah. So
the same in the car. The car's the same way. Crank the heat, turn the windows down.
now, see, in the car though, I don't have any problem with it because you're not using like extra energy to do it. It's heating the air off the engine that's actively already doing something else. But this, you have to use extra energy spent for the purpose of heating your apartment. It's not like a side heating. So if you could turn on this little heater and it really just came from the boiler down below in your basement or something.
The hot springs underneath the building.
Yeah, exactly. Then great. That all works out. It's you're using extra energy from another thing.
Well, I don't know what to tell you, Case.
That's all right. Just maybe try to be better.
Oh, fuck you. Casey, let's imagine as we do every episode that you and I are walking along somewhere in New Zealand where these trees grow. We come across a tree. Now, it's going to look a little different, but I will still recognize it as a tree.
You will. In fact, you'll. Yeah, I think there would be no question about it.
But there's still something a little off. And I say, Casey, let's ID this tree.
I'm so happy that you say it that way, but I'm also, it's a little bit, I disagree. You're going to walk into a tree and you're going to look at it and you're going to be like, oh my God, that thing's huge.
Oh, wow.
It is the Totara, which is Podocarpus totara or Totara, or my cousin Podocarpus totara. I always say my cousin. I think that's a little funnier. So we're going to call this my cousin Totara. So that is a species of podocarp. And the scientific name is Podocarpus totara, which is lovely because the common name is just Totara.
Should we up top, before we start talking about podocarps, we're using this word a lot. Let's define it really quickly.
Oh, I would love to because Alex, we're going to talk way more about it.
Oh, okay. Should we hold off then?
No, this is the perfect moment.
Okay, let's do it.
This is allegedly the biggest genus of conifers in the world.
This is surprising. It's subverting my expectations.
And this is why I said we are remiss for having gone now 3 whole years and not ever covered a single one. But the reason that it's not covered by me is that admittedly, we have a Pacific Northwest bias.
A bit.
It's because this is where we are. This is what we know. This is the most, this is my experience as an arborist, as a tree person. I go outside and I see the trees.
And we don't have podocarps here.
We don't. In fact, podocarps are almost exclusively a southern hemisphere tree species, genus, everything, even the whole family, because there is a whole family called Podocarpaceae. So this is a family that it's very closely related and allied to the Arbortrary, which are the monkey puzzles and their ilk.
Yeah.
And those two are all within this one big family, the Arbortrales. I love that.
Arbortrales?
Yeah. So if it ends in A-L-E-S, it's an A-alley or A-ly. I just think it's fun.
Is that the family?
That is the order, actually.
Order. Oh, my gosh.
Yeah. So there's only a few orders. There's like the cycads, ginkgos, the knee-tails. Don't even ask about it. And this is all under like conifers.
Okay.
And then there's the pineales, Araucariales and the cupressalis, or rather the Pinales, Araucariales, cupressaliales.
Oh my God. This madness has to stop.
Yes. Now I think I added in an extra syllable there just because it was more fun that way.
I'm positive you did.
Yeah. Anyway.
Podocarpaceae is
right.
is the family here.
Exactly.
Podocarpus is the genus.
Yes.
And today we're talking about
Podocarpus Totara.
Totara.
Yes.
Okay.
So Totara, I've also heard. This is a Maori word. It's a Maori tree. Of course, they are the people who've lived there since I think I read 1280. So they've been there for nigh on 1,000 years.
Okay.
And they've named all their trees just the way any indigenous group has named all the trees and plants around their area. And so one thing I do love about New Zealand is that they have tended to either go back to or put forward the indigenous names for the trees rather than calling this the black pine of New Zealand.
Right.
It's like, okay, let's actually give this the name that was initially given.
That is cool. Kauri is the same way.
Exactly. Yeah. So, and actually quite a few trees in this same family. So Podocarpaceae, the family, has 174 species. Everything in Cupressaceae, the cypress family, which includes Taxaceae, which includes Taxodiaceae, which is the redwoods and sequoias and things like that. That has 154, so it's just a little bit smaller as a family.
Okay.
Now, the biggest family of these funny little trees is the pine family. Pine family has 234 species.
I thought you said that Podocarpus had the most conifers.
It does. The genus.
Oh,
so the family, biggest family, that's pine family, which includes your true firs and true cedars, your larches and spruces, pines, that kind of thing.
Mm-hmm.
Now, Podocarpaceae is not unknown. It's very well known, but only because it grows down in the southern hemisphere is it not so well known to people up in the higher latitudes.
This is Pinus country, or this is Pinaceae country.
Exactly. Yeah. Yes. Pinaceae country with a little bit of Cupressaceae, but then so this is a whole family that has been it's a Guandanan family. So it was growing along with the Araucarias down in the supercontinent in the southern hemisphere called Gondwana, which included Australia, New Zealand, actually India, interestingly, Antarctica, Africa, and South America.
Okay.
Everything up above that was Laurasia. And this is after the giant big Pangea supercontinent broke up. Mm-hmm. Everything in the north, which now is Asia, Europe, and North America, those were all Laurasia, is what it's called.
So you'll find similar types of plants up there.
Yes.
In the northern hemisphere.
Yeah, correct.
And then similar types in the southern hemisphere.
Exactly.
This is like in in A Song of Ice and Fire. I feel like Podocarp is like Dorn. Like
now
it's not a big part of the story.
You better be careful. You're towing a line here.
No, I think I'm safe.
All right, just making sure.
I will not mention the F word.
Thank you.
Yes. It's like Dorn. It's like it's a huge chunk of the continent.
Yeah, yeah.
But it's like not talked a lot about in that story because the story takes place in sort of the northern parts.
More of a northern thing. Yeah, exactly.
Northern parts.
Yeah.
But then it's like this huge thing. Of course, southern hemisphere. I'm sure Podocarps are extremely well known. They
are very well known. Now, let me give you some of these families, or rather, some of the genre within this family.
Okay.
There's Acmopyle, Afrocarpus, Dacrycarpus, Dacridium, Falcatifolium.
Wow.
Halocarpus, Lagerstrobus.
Lagerstrobus. All right.
Now,
I know a guy named Lagerstrobus.
Yeah, I met him over at the pub. He was drunk as hell.
Lager. Well, it's in his name.
This is Lager. It is exactly.
Is it really?
Yeah. Now, here's a fun one that we're not going to be able to talk about, but maybe I can convince you to let me do some research on it and get paid for it. It is Parasitaxis.
Parasitaxis.
Yes. Now, what does that sound like to you?
Taxis is like you.
That's you. Yeah.
And Paris is like parasite.
Aha.
Parasitic you.
Yes, this is it. It is, so far to my knowledge, the only parasitic conifer.
Holy shit.
Yeah.
Well, let's definitely get into that someday.
Okay, now it only grows, according to my calculations, 1.5 meters tall, which is not a tree, demonstrably. So we can't cover it here today. I'm sorry.
But it is in the Podocarp family.
Yes, that's correct.
Podocarpaceae.
Exactly.
Okay.
So back to our tree that we are talking about today.
Yeah.
This is the Totara. So this tree, and again, everyone, you have to give us a pass if you're down in the Southern Hemisphere. You hear us say these words and you're like, what idiots? Their mouths do not make the right sounds. We're sorry. The podcast regrets the error. Mm-hmm. Now, this is a tree that in its native habitat gets huge, easily up to 100 feet or 30 meters-ish tall. And it can grow a stem diameter of over 12 feet.
Wow.
Huge. Like another gigantic tree. So when you were saying you walk around and you see this thing that looks like a tree and you're like, what is this?
It'll be a tree. Okay.
Yeah, you'll know it. The thing that looks different is that as it gets larger, it kind of looks like a big bushy shrub. It looks like if a yew just went massive.
Yeah.
So its leaves are very yew-like. So they're very kind of dark green, almost brown color. And they are linear, which means they are flattened, not quite needle-like. So if you think of a spruce, they're like either in squares or triangles if you cut them in cross-section.
Yeah.
And they look like needles. They come straight out. Whereas this, they look more like a grand fir or a yew or another species that has kind of, if you take what you think of as a needle and you smash it down and you pin it out and it becomes a flattened kind of lance-like thing. It's not quite broad, but it is definitely a flattened linear looking leaf.
I would say it's sort of the shape of like a French roll.
Yeah, okay.
Or like a short baguette.
Yeah, but completely flat.
Yes.
Yes,
yeah.
exactly. It's the outline of it.
Yes.
Yes. Okay.
To me, I would describe this as just little lanceolate leaflets.
Yes, that's perfect. Yeah.
Little long leaves.
So they are just gorgeous. They're pointed at the tips. They're a little bit pokey. You're not going to want to go and shake hands with this tree for too long. And they come out spirally arranged.
Cool.
But often, Alex, they come out spirally arranged and either come out left and right. They kind of look like they're opposite because they go out left and right sometimes. But often you'll see them just coming out in every direction. So they tend to have these kind of two main forms of growing.
Like per tree.
Yeah, and also like where it is on the tree, higher up or lower down in the sun, in the shade, that kind of thing.
I'm reminded of what is another? Is the monkey puzzle spirally arranged?
Yes, monkey puzzle is spirally. Most of the firs, everything in the pine family is technically spirally arranged.
Okay.
It just so happens like the grand fir, for example, its needles are connected in a spiral pattern, but they grow out perfectly horizontal, so they kind of twist and then grow flat. Okay. So they look like they come out opposite left and right, left and right, left and right, but they're actually, the ones on top grow 100% off to one side. The ones on bottom grow 100% off to one side.
Gotcha.
So they just kind of make you, they're a trick.
Okay.
So that's the first thing you're going to see. And as this tree grows older and gets bigger, it kind of loses its top. It kind of becomes a little dead top, kind of like what a western red cedar would look like. And it looks to me like, it's a gigantic tree, big and thick, doesn't always get super tall unless it's in a big forested area. So you can get these big monoliths that look like these gigantic, big, huge columns with kind of these puffs of like new foliage coming out. Like it looks like you have little trees on top of big trees.
It's very soft looking. It almost looks like one of those big, like a Toy Story cloud.
Yeah, totally.
It's sort of bubbly and
that's a great description. Unfortunately though, like I said, it is pokey. So it's going to poke you.
Like sharp?
I think it's kind of like a medium-sized spruce. So you touch it and you're like, ooh, all right.
Okay.
But it's not going to be like, lay down and have, someone come over, give you some air, splash water on your face. I don't think it's going to be that bad.
To remove them like porcupine needles out of a dog's face.
Exactly. So I don't think you'll need any tweezers.
Okay.
But they're also not very big. So it looks a lot like a yew. And the tree gets really big. It has kind of more or less utility bark, but it looks more like strappy and fibrous-y. So it looks a lot like what you'd expect a cypress tree or something to have.
It's a good looking bark.
A little shreddy. Yeah, I think it's very attractive.
I think even like cypress looking utility bark is like better than, I don't know, pine utility bark.
I think you're onto something there. I think you're right. Now, the thing about the Podocarps is really kind of what set them apart and a lot of their family. But they are not the only ones to have this distinction. There are other trees that do a similar kind of thing, but the Podocarps are like one of the top examples of this.
Okay.
And they have cones that the only way we can call them cones is when we say, in a technical sense, these are cones. It's almost to the point where we say these aren't conifers, these are gymnosperms, because their cones, very similar to the U, are so reduced to the point where they just essentially don't exist.
What are they?
They are technically cones, but what you see looks like a red berry with a seed perched on top.
Oh, yeah.
And if you just Google it, you can find lots of different pictures of podocarp. Just look up podocarp fruit, and you'll find a picture of it, very simply. And it is really unique. And I had to figure this out. I did the same thing for U's because there are a lot of ideas of what exactly it is. So I ended up going to the trusty A Natural History of Conifers by Alios Farjan.
Yeah.
So he made this great diagram to show how the podocarps work. And essentially, they have a tiny, single cone scale-ish kind of thing. And that little tiny thing is called an epimatium or epimadium.
Epimadium.
I think epimatium is probably a better description of it.
Okay, and that's the name of the scale?
Yes, it's essentially this. It's the best way I can describe it without getting so technical that it makes this an unlistenable show.
Yeah.
Let's just call it a scale.
Okay.
Then on either side of that are two bracts.
Okay.
On either side of those, or in the middle of that epimadium, is the pollination drop.
Pollination drop.
Yes, that is essentially a bit of liquid that will capture pollen as it hits.
Oh, it's like a little fly trap for
Exactly.
pollen.
Yes, exactly.
Wow.
So it gets stuck on, and then the pollen tube finds the ovule, fertilizes it. When that happens, those two bracts that are on either side, kind of, holding it together, they start to grow bigger almost immediately.
Okay.
So they start to grow bigger, and they fuse together.
Wow.
And that central kind of axis that they're on elongates a little bit as those two things also get bigger and fuse together, those two bracts. Then the epimadium or the epimatium closes over the top of the little tiny ovule, which is the seed that starts to develop, and it ends up creating this long kind of aril receptacle. Do you remember what a receptacle is?
No.
Excellent, Alex.
I did as deep a dig as I could in 2 seconds.
The receptacle is the bit that holds a flower onto the stem.
Okay.
So onto the actual trunk or whatever it is, the pedicel if it has one.
Okay.
So that is essentially the bit that subtends the flower and the rest of the fruit that comes afterwards. So in this case, it's not a true flower because they don't flower, but as soon as it gets pollinated, this becomes the equivalent of a receptacle. So everyone's like, well, that is the receptacle. So it gets the term. Receptacle gets fleshy. Those two bracts fuse together and they become a big red berry-looking thing.
Wow.
That big berry-looking thing has this seed that is on the top. That seed looks like it's just sitting there. Like it looks like a fake piece of candy. A lot of times they're like a little bluish, brown, blackish kind of color.
Interesting.
So it looks a lot like, if you just Google photos, you can find lots. And it looks like there is a fruit snack that's red, like a raspberry or a strawberry fruit snack with a little blueberry fruit snack sitting on top.
Yummy.
So it looks like. And it looks delicious. Like, I won't lie.
The process that you just described to me reminds me of like when you're a kid and you come up with something really imaginative, or you draw. Did you ever like draw things, like draw mechanisms when you were a kid?
Yeah, I think so.
First, this drops into this, so then it hits this and it grows into this.
Yeah, I think it did.
I felt like your mom and like you were a little kid describing this weird thing you came up with.
And then it does this, and then the bracts become this. Oh yeah, buddy, that sounds great.
And then it becomes really fleshy, and then a seed comes out.
Okay, Casey. What have you been watching recently?
Why do you know that word? Yeah. How strange! It's so alien.
It's very alien, yeah.
Wow.
And all of these plants, they developed right at the end of the Cretaceous. So they don't go too far beyond that. And that's essentially 65 million years ago.
It shows.
It does show. Wow. You're like a little Cretaceous, okay?
You didn't develop until the end of the Cretaceous, and it shows.
And it shows. Oh my God. How could you say that?
So rude.
Yeah, so they really, the whole family probably evolved in the Triassic, which is like 220 million years ago.
God damn.
Yeah, but the Podocarps, like this specific group, so don't worry about the names and why the group Podocarps, meaning like Podocarpus, the genus, evolved in the Cretaceous, which is like 65 million years ago, near the end. Yet the family itself is way older. Just don't worry about that. I
don't even know what you're saying enough to worry about it.
Thank God, Alex, thank God. So at the end of the Cretaceous, about 65 million years ago, is really when this family started, or is really when this genus started to develop. This is also coincidentally when the land masses of Gondwana started to separate, specifically New Zealand. Yes.
Okay.
So all these Podocarps have a really interesting history in this southern area, and it has a lot to do with their fruit.
Okay.
So you're familiar with angiosperms, right?
Yes. Hold on. Angiosperm. Mm-hmm. Inside. That's inside.
Kind of.
Hidden fruit.
Yeah, all right. Yeah.
Hidden, that means that there's the seed.
Our scorekeepers are giving you points for that. Yeah. That's good.
There's no way they would.
Thanks, Bill.
The seed is hidden, meaning it's inside a fruit.
Yes. So it is a covered seed.
Covered.
Yes. Covered. Which is why I think you get credit. Hidden, covered.
Okay.
Same thing.
Yeah, exactly.
I think in this case.
The Jeopardy judges would give me that one.
Exactly. Bill Curtis would give you that.
Thank you. And then gymnosperm being uncovered.
Yeah.
Like a ginkgo.
Exactly.
Or
naked.
Any pine or
Precisely.
Most conifers, right?
Yes, exactly. Okay. Including our Podocarps.
Okay.
So remember that little droplet with the ovule right there that's just exposed out to the world?
Right, yeah.
It's exactly the same
Uncovered,
thing.
Okay.
So it's just sitting out there in the open. Essentially what this is as you have conifers, the way they develop is they have a cone scale and a bract. These compound things where there's always those two bits. Now, in the cypress family, the scale has been reduced to almost nothing, but the bract has become bigger, and that is what the seeds are sitting on top of. So what we say as on a cypress cone, look at those peltate scales, for instance.
Yeah.
That's really, we should technically probably be saying, look at those peltate bracts.
Wow, okay.
But it's an arbitrary distinction, Why did we choose one to be the scale, the other to be the bract,
Sure. Okay. But they, like, for all intents and purposes, in that case, the bracts are the scales.
Exactly. Yeah.
Colloquially.
Yes. Now, the rest of the botany going into this is really complicated. So if you want to get into it, everyone, please go pick up your copy of A Natural History of Conifers by Alios Farian.
All right.
So he goes into it in here. The easiest way to think about it is that there's this compound bit. There's a scale and there's a bract. The scale, for all intents and purposes, is a old modified leaf. Mm-hmm. So on conifers that we're familiar with, let's say true fir, that branch initially would grow up and it would have what used to be leaves coming out. But those leaves get turned into these fertile things that start producing ovules. So as soon as the genes say you are now a fertile shoot, then instead of producing normal leaves, they produce scales and bracts.
Okay.
So then you have all these little ovules on it. They are spirally arranged, and that little thing we call a cone, that little short shoot of modified leaves.
This is what you say when we say like modified leaf tissue.
Yeah,
They all kind of start as the same thing, and then the DNA says you're going to become this bract.
Exactly.
You're going to become this leaf.
Precisely.
You're going to become a cone scale.
Yeah, you got it totally right.
You're going to clown school. You're going to law school.
What? Captain Gene. Sorry, it's just the way it is. It's just the way it is.
Captain Gene.
Yeah, it's kind of a weird thing. I think someone, who was it? It was like an old philosopher sometime, said essentially everything is just a modified leaf. Like,
Interesting.
you can really think about almost everything as a modified leaf, except for maybe stems. Stems are probably the one thing that are kind of really different, maybe
Okay.
roots even. But roots are probably just modified stem tissue.
Sure,
So
yeah.
how far you want to go back, it's all subjective at some point, but we might as well just say here, this is the same mechanism, but instead of growing up like a true fir and becoming big and having multiple spirally arranged little individual bits, they've reduced it down to one. That one has one ovule on it. That one ovule gets fertilized and becomes one seed.
Cool.
So that is what they have done. But the thing that makes them separate and different is that they, like the yews, and to some extent like the junipers,
Yes.
have developed this fleshy appendage. In fact, the yews are probably the closest
your
ones.
pardon?
Excuse me. The yew have a fleshy appendage.
You have a fleshy appendage.
Okay, thank you. I'm gonna go.
It's like a doctor's appointment.
Well, that's one of the three things that sets this tree apart, which is kind of what I wanted to talk about. So you asked, Casey, could you tell me a little bit about these Podocarps?
I see now that this is the whole thing.
This is the whole thing.
Yeah.
We've actually been in the episode for 20 minutes now.
My friend.
Uh-oh. Don't tell me. Don't tell me. So what's cool about this is, remember, we have Gondwana, which is now many multiple different individual island groups, let's just say, where you have Africa and South America. Yes, I know they're not islands, but let's not get into semantics here.
Are we in Gondwana times right now?
Yes, let's
Okay.
start there. So we're in
Is
Gondwana.
Gondwana in the room with us, Casey?
I think so. Hello. So it started. It started to split up, and this is when Antarctica was a forested wonderland.
Wow, really?
Yeah,
It's hard to believe.
it is so hard to believe, and the main reason that it is what it is today is that when the continents of Africa and South America split off, then the ocean currents changed and started to essentially rotate around the continent at the bottom of, we call it the bottom of the world, because we've decided, again, arbitrarily, one way's north, the other's south.
Sure.
People tend to think south is down. It is not necessarily right. It's just one interpretation.
Just that way.
It's just that way. So right down at the pole, we have this new current that starts to go around and essentially caused Antarctica to become frigidly cold.
Okay.
And everywhere above it, because it's obviously at a pole, it has that warm and cool temperature, just the way we do up in the Arctic. But same thing down there. If you start to go up the latitudes towards the equator, it gets a little warmer, It becomes tropical or subtropical, then tropical, then it starts going back down towards temperate as you move up to the northern hemisphere.
Sure.
So down in this Gondwana land, there were Podocarp.
All right.
There you go. It lives, it exists. As it started to split up, uniquely, that is when the Podocarps also started to really blossom and become species. And you can trace the Podocarp as a genus, Podocarpus. You can trace it basically, where are the species and which ones are closely related to where they live. So Australia, New Zealand has about 6 species. They're all within their own clade. That branch of the family tree, all related. The Africa, the subtropical Americas, tropical Americas, New Caledonia, Fiji, Indochina, all these places that have any species, all those species are very closely related to each other in that region.
Are those species also related with the other clade?
They are, but only very distantly.
Really? But they're all still Podocarp.
Exactly. So they're all in the same genus. They're all very closely related, just like we have lots of pines. But the difference is what happened in the southern hemisphere is that you had this one big mass covered with the original trees, right? Or maybe the original tree. Then that split into 1, 2, 3, 4, 5, 6, 7 different places.
Okay.
As they split, now it would be like you and me are brothers, and now you are on continent A, I'm on continent B.
Okay.
So my family becomes the Caseaceae. Yours becomes the Alexaceae. So these are horrible names. I'm sorry, everyone, for the confusion.
Like
okay, great. I'm happy you do. So we are closely related. You and me are brothers. But as our family goes down, my kin looks like me, your kin looks like you.
Sure.
Not so distant from each other because, well, our parents are very closely related, but you can see very clearly how these things happen.
But also, as we create more offspring, and as our offspring create offspring,
find their niches and things like that,
those are getting less and less related to each other.
Exactly. Okay. Precisely.
Okay.
And that is what happened.
It's been 65 million years of this.
So there's a lot of time.
So that's
right?
that's a lot of speciation.
Exactly, yeah. So these trees, all the Podocarps have done that exact thing.
Okay.
So they've all moved around, and you can find all these different species across. And what they did, and specifically in New Zealand, specifically Totara, has used their ability to create this very particular kind of non-cone cone to compete with another kind of tree that is growing down in these areas that's far more successful, and that's the angiosperms.
Oh, wow.
The angiosperms. Oh, wow. Yes, these are the fruiting trees, the trees that make flowers and then produce fruit that are eaten by birds.
And just to clarify, because I need to say this thing over and over to understand it myself.
Say it out loud, Alex.
Angiosperm is hidden
covered
seed.
Yes.
And if you are wondering what the fuck that means, think of like an acorn.
Yeah.
The seed is in that acorn.
Exactly.
It's in this little house.
It's inside that what used to be an ovary.
Or a peach. The seed is covered in this fleshy, mature fruit.
Yes.
It's hidden.
That's perfect.
As opposed to like a pine cone. I'm saying pine cone.
Yes, from a pine tree.
Yep.
Yeah.
You can look at the seeds. You can see them in there. You can shake the thing and then they'll come out.
Yeah. And now if someone was to respond, well, aren't they covered by the cone?
Not really.
You would say, yes, exactly. Not really, because it's the ovule that is really the thing that's initially covered.
Yeah.
So the ovule is tucked away inside fused carpels, and that basically means the same thing. Again, modified leaves. These modified leaves covered over the top of the seed and hid it away, so that in order to get to it, you have to go through a essentially giant mechanism of keeping everybody else out, which we call a flower.
I probably wouldn't say that to that person.
That's fair.
But I wouldn't know to say that. I would just say, no, not really.
And just walk away. God, I really didn't learn anything from that guy.
Okay, so the Totara they're sort of like a stranger in a strange land.
Yeah.
And they're in angiosperm country, and they've got to adapt. So they kind of like paint themselves to look like the angiosperms.
Yeah, exactly.
Okay.
And now New Zealand is famous for its birds. And they have had, they've been separated from Antarctica and then more broadly from Australia for about 65 million years. They were touched and got a little closer and then went away a few different times kind of in that period. But for the most part, the flora and fauna of New Zealand has been the flora and fauna of New Zealand for something like 65 million years.
Yeah.
With very few other things coming or going. In fact, there's one instance they say in, again, one of my favorite places, the Gymnosperm database.
Oh, yeah.
It literally, the second paragraph says there's an unsolved mystery of biogeography affecting P. Totara, which is Podocarpus Totara, where there is another species that it looks almost exactly right, which is Podocarpus nubigenus.
Nubigenus.
Yes. Isn't that a fun name? That seems like some kind of planet somewhere, just to be clear.
Hey, look at your Nubigenus. It looks great.
Oh, thank you. I just got it redone. Oh, my God.
And that Nubigenus energy.
Yeah, you got it. You really got it. So it's another species that grows in the Valdivian rainforest of South America in Chile. Okay. So we don't know. Nobody knows. There's a few other examples there where this is a species that looks morphologically just like the Totara.
Interesting.
But they can't figure out. There had to have been some dispersal thing because over 65 million years, just like you said, the offspring would look way different.
Okay, so they can't even assume that maybe they have an ancestor in common because they look so similar.
They're like, they must have an ancestor in common that's way younger than 65 million years.
Yeah, that's what I mean.
So they're thinking that a bird at some point must have taken it over, but they don't have a good answer. They're just guessing.
I mean, we've talked about that is really the only way. I guess a seed needs to get from point A to point B, island A to island B.
Yeah.
You have wind dispersal, probably not going to happen.
Probably not. It doesn't take it, hundreds and thousands of miles.
Sure.
Or rather, hundreds or thousands.
Or rather, maybe the wind dispersal could get it partway, it falls into the ocean, and then the tides bring it in or something.
Very potentially, if it can withstand being submerged in salt water.
That, and if it lands on the sand, it's not necessarily going to take.
It's not the right habitat.
Right. You have birds. They eat the seeds on island A, fly over to island B, and poop it out.
There you go.
There's one. People. I'm thinking canoe plants.
Yeah, exactly. Which, funny enough,
canoe crops.
This is a canoe plant in that the Maori made canoes all out of the way the Pacific Northwestern tribes would make one gigantic canoe out of the Western red cedar. Yeah. Same thing with the Totara. It was a very, very revered tree. Has been their entire existence.
Interesting.
So you're totally right. Nobody knows.
Interesting.
Nobody knows. But all this to say, the other two things that they are able to do, Podocarps kind of broadly, they are very able to take poor soil conditions. And this is because they have ectomycorrhizal relationships.
Okay.
The one species of tree that they compete with in New Zealand, like in terms of like forest dominance. Now, not the Totara. It turns out that's actually not a dominant forest tree. It's a dominant tree that you can find in a forest, but it's not like our Douglas fir where you'd see it growing in giant, big forests of itself.
Like a monoculture of Totara.
Exactly. It's more like a Western red cedar, and then you're like, oh well, there's one. Oh, there's another one. Like, oh, there they are. So they're big trees. They'll grow in lots of spaces, but they can take this ectomycorrhizal fungi, whereas the dominant angiosperms, those are the nothophagus. We call them southern beeches. They have endomycorrhizal associations, which we also today call arbuscular mycorrhizal, which goes into the cells and creates little trees. That's why it's called arbuscular.
And then ecto is outside.
Exactly. It's essentially a sheath that goes around the roots, and then they transfer stuff. But they don't actually, nobody crosses over any boundaries in a strict sense.
Yeah.
So that is its big thing, and they compete. So one tree cannot really move into the soil space of another tree because it doesn't have the right fungus, because the fungus is competing in the soil. And if your fungus is winning, you grow there. Isn't that
wow.
fun?
Yeah. So it's kind of out of their hands.
Exactly.
It's up to the fungus.
And it's not so black and white. There's 1,000 different things that come with it. But yeah, that's a huge reason. It's just the fungal relationship keeps some of these trees able to grow and compete with the angiosperms.
Very cool.
The other thing is, I was telling you their leaves are kind of like a little flatter. Well, some of them can get really long and others get very wide. So they actually have emulated broad leaves by broadening their leaves.
Is that within the genus?
Yes, within the genus and within several others that kind of do the same thing. A lot of actual things in the Taxus family, Taxaceae, which is the yew family. They also do a similar thing where they just kind of create these wider leaves that look a little bit more like broadleaves. Now, no one is going to tell you they're broad leaves, but you could look at them and say, yeah, well, they're not needles for sure.
So I guess like is it necessary for Podocarps to kind of replicate or mimic broadleaf trees in order to compete with broadleaf trees, or could they just like do their own thing and compete in their own way? Because I feel like this, I don't know this, I haven't heard this a lot where like trees are like adapting by becoming more like better competitors.
Yeah, well, I can tell you that the Podocarps are probably the example where they have, and the reason why I can say they have to compete this way is because they're the only ones who've successfully done it.
Okay.
Almost every other space in the world, conifers have been pushed out of, except for the extremes.
Yeah.
So over here in the Pacific Northwest, we ended up getting just a climate that was so perfectly adapted to conifers that they will just outcompete. Same thing in Japan, in high mountains and high latitudes. But in all of these other spaces, you have found that whatever advantages are in the broadleaf trees, the angiosperms, that has been more successful. Go down to any tropical forest, you'll be hard pressed to find one single conifer until you get to really dry or really poor soil conditions. Then the conifers start to dominate.
Interesting.
So in this case, podocarps are able to compete at the big tree level in certain habitats in these areas, mostly the tropical areas. They do not grow very often in the really hard, awful, warm soils, the way you'd find junipers and the sequoias and trees that we have around here. They just don't exist.
So they have the genes of a conifer.
Yes.
But they're sort of living the life of a broadleaf tree.
Exactly.
Interesting.
Yeah. Up to the fruit, because it worked really well for the broadleaves.
Yeah.
So they modified their fruit and they got birds to do all their dirty work for them. They are growing with a little bit broader leaves and they're able to compete in the soil where other broadleaves may not have such an advantage.
Interesting.
They also have this specific shade tolerance that is a big thing.
Okay.
So they can grow in bad soils in the shade, and then they can get birds to do their dirty work for them, to move their species around. And they have been successful. So to answer your question, I guess so. Yes, they have to mimic these broadleaf trees because what they've done has been so successful.
Yeah.
The only way to also be successful is to do the way they do.
Interesting.
Yeah. So
I kind of like Podocarps.
Hey, they're very interesting. We're going to talk about a few others in this family before the end of our journey down to New Zealand.
How about that?
Yeah.
Well, Casey, before we give our review, how exciting!
I'm very excited
of this Podocarp. We got to take a quick old break. We will be right back with our review of Totara. Welcome back.
Thank you, Alex.
It's completely arbitrary. That was our discussion of the Totara and Podocarps at large. Casey, it's time for a review of the Totara. Here's how it works. We're going to give some final thoughts on this tree and then give it a rating of 0 to 10 golden cones of honor. Little fucked up berry looking cones.
Wow, I resent that description.
Hey, that doesn't mean they're not cool. Casey, as our resident expert, we'll begin with you.
Well, all right. This is such a complex tree.
Wow.
just to jump into talking about it, I opted today to talk a little bit about this whole family of trees, or not even the family, just the genus, right? And we could still sit down and talk about all the specifics of this particular tree and even the history of conifers in New Zealand, but we can't do that. So this is, I think, a tree that is similar to the kauri in that it's like, whoa, like it's big, it's gorgeous, and it grows in like really interesting ways where it has this, like, I don't know why, but it has this growth pattern that just looks different. When you see it, you're like, yeah, that tree does not look like a tree that's in our area.
It kind of looks AI generated, if that makes sense.
Oh, wow.
Do you know what I mean?
I don't think so. We may be looking at different photos. But
I don't
Either
think
way.
we are.
Okay, yeah, we always
Just how I interpret
see
that.
the same things.
Yeah.
Well, that's a fine way to describe it. I think it's just like it's a weird tree, but it's in a way that I love. Like the perfection of a tree is in its flaws, in my opinion. So as a giant tree is growing up and it's falling apart, its crown is becoming more complex. You can see where it's died. You can see where it's got struck by lightning. You can see all these other weird things. You really get the sense that that's seen something and it's had to like adapt to all these, harsh things that have come down on it. I think that's what makes a tree beautiful.
Totally.
I also
complexity.
think exactly.
It's like a wine, right?
Yes.
Like I don't know anything about wine, but I do know that like the really, really, like the amazing wines.
Yeah.
You apparently like take a sip and you're like hit with this just barrage of different tastes and senses and things.
I've also heard that. And I think you also need
complex.
to you need to know what you're looking at, or so like what you're tasting in this case.
Yeah, or like umami is like that fifth thing that's like we don't even know how to describe it. It's like really rich and deep.
Yeah.
That's how I feel about those trees that have like you could map their canopy and it would look like, a crazy cityscape or something.
Exactly. It would look wild.
Yeah.
So that's what I get from this tree. And it's so sad that over time, I think the forest that used to cover New Zealand of like, it was 80 to 95% forested.
Wow.
It's now about 25% or the whole country.
Damn.
So that was not just because of the Europeans. As soon as the Maori came over, they introduced fire, and scientists believe that there was no fire, like except in the very rare volcanic situation on all of New Zealand.
Interesting.
Yeah. It has a climate similar to the Pacific Northwest in that it's just rainy all the time, but there's no dry season. So it just is rainy all the time, but it's kind of like a subtropical half-temperate rain. So it is warm and it rains all the time. And so it's this very wet place. As soon as the Maori came, they introduced fire because it was a very intense part of their culture. They then used it in a lot of different ways. When the Europeans came and then colonized the islands for the second time, you then saw this gigantic, like, grasslandification. It became nothing but like habitat for sheep. Farmland, pastures, things like that. So this tree used to cover everywhere. And it was really important. Like I said, very, very similar to the Western red cedar. And I just think that is, like, I just love that kind of thing. Like walking through a forest and seeing this huge, gigantic tree just off in the distance with this wildly complicated canopy that looks amazing, that is covered in birds, but it's a conifer. Ooh, it just gets me going. So I think I'm going to give this, because I am just a fan of conifers and giant trees, a 8.9.
Very good.
Going to give it an 8.9 because
can't help but notice.
I like cones. And that's where this comes down to. You're right. This is a cone-like thing.
Hey, a cone-like thing.
It's
please.
a cone-like thing.
It is a cone, Casey.
I see that. It's like I've even read things that do not go as far to call it a cone.
Do you call it juniper, quote, berry a cone, or a yew berry a cone?
Yes, I would.
But not
Well,
this.
no, not even the yew, because it's a single seed with fleshy bracts.
Yeah.
So the yew is the same thing, where that fleshy bract just comes down and goes around the seed, and kind of like, it's almost like a shade, like a lampshade over the seed.
Yeah.
Whereas this, it develops underneath it and kind of puts the seed right out in the top. So it is just demonstrably not cone-like.
That's fine. Well, Casey, I think that the Totara is pretty cool. I think this tree is pretty cool. I like this Podocarp business. I'm shocked that we haven't talked about any so far in our 3 years as a podcast.
I like that you looked at the clock there.
I don't know what I was looking at. I like, you don't call it a cone. I think botanically, though, it is, right?
In a technical sense, it is a reduced cone to the point of being a essentially single scale.
But it is a cone.
Technically.
It is a cone. This is my time. Get off stage.
Sorry, I'm gonna get pulled off by the cane around my neck.
Yes. Yoink. Your hat floats midair for a second. So I like this tree well enough. Of course, no emotional personal connection to it, but hey, that's my fault for not being born in New Zealand.
Yeah, way to really fall flat there.
I'm so sorry. This seems, I know that when we did our Lord of the Rings, another $1 series, we talked about the pedunculate oak being the type of tree that would grow on top of Bag End,
Yes, yeah.
I could see this tree being that tree.
Really?
A big, beautiful Totara on top of Bag End makes perfect sense.
All right.
I love the kind of interesting needle-like leaf-like needle-like leaves. I love any like the yew. I love those leaves as well. And the yew, kind of an interesting take on a cone. I think it looks a lot better than this cone.
Really?
I think this cone looks a little shoddy, maybe.
A little shoddy, okay.
A little like unintelligent looking. Wow. It's just sort of like jammed in there,
it's like a
the seed.
Knobby.
Yeah, the seed is just kind of where do we put the seed? Just put it on top.
Was that your first draft? Okay.
It looks like you made a cake, like a birthday cake, and then your kid was like, I really love Toy Story now. And you're like, oh, fuck. And you just took his Buzz Lightyear doll and stuck it into the top of the cake.
Yeah, I see what you're saying. Yeah.
It doesn't look that smart, but it's fine.
Yeah.
I think I'm going to give this tree like a 7.75.
7.75.
That feels good to me.
All right. Okay.
Yeah.
I think I'm okay with that.
I think it's an all right tree, and I'm excited to see what's next. Do we want to give a little tease, or should we just move on?
I think we should just move on.
All right. Well, that was our review.
Sorry.
Of the Totara. Casey, it's time for our completely arbitrary AMA.
Well, that's what I'm talking about.
Casey, this question comes from our AMA section on our completely arbitrary Treemium platform. If you want to join up and support the podcast, ask us questions, get bonus content, get monthly cone stickers illustrated by different artists, join up on arbitrarypod.supercast.com. There's a couple different plans there. You can pay annually, monthly, you can gift a sub. It all helps the podcast. Casey.
That's right. Yes, Alex, what do we have today?
This one comes from Rex Wu.
What's up, Rex?
Howdy, Rex. Hey, speaking of Toy Story, Rex says, Kill, Marry, Kiss.
What?
Casey, Alex, is this game played on the show before? Among all the tree species, which one would you pick and why? So this is sort of turned into a Q&A section and a game.
Yeah. Except I've never played it where the last one is Kiss.
Yeah, I think Rex is being PG here.
We really appreciate that, Rex. Okay.
So the idea here, Casey, or if you haven't heard of this game, is that you have an option of 3 things, and you get to select which one you want to kill.
Yeah.
You have to kill one of them, you have to marry one of them, and you have to, we'll say, kiss one of them.
Now, does Rex give us any specific trees?
No, but I have decided to do this for us.
Okay, Alex, thank you. This is a little bit of a game now.
Yeah,
here we go.
exactly.
Okay. All right, okay.
Okay, Casey, so we are going to go with kind of a classic, maybe a gimme, but a Douglas fir.
Okay, all right.
That is Metasequoia. No, it's not.
It is nowhere near that.
It is Pseudosuga menziesii.
Wow.
Douglas fir.
Okay.
We are going with thorn mimosa.
Thorn
acacia.
Mimosa.
Yeah.
Yes. What is that? It's Vicellia mimosifolia.
Vicellia mimosifolia.
I believe that is
not
it.
acacia.
Yes. Well, it used to be an acacia.
That's right.
Yeah.
Thorn mimosa, Douglas fir, and I'm gonna say a cowrie.
A cowrie.
Yeah.
Whoa. Jeez. Okay.
Kill, marry, kiss.
Kill, marry, kiss.
Or mommy and daddy wrestling.
Wow.
Yeah.
Okay. Well, the more I learn about Douglas fir, the more I'm I just don't know. Did you know that Douglas fir is invasive down in New Zealand?
Do you want me to go first?
Are you ready? Then you should.
I've got one at least.
Okay.
I'm going to marry the Douglas fir.
You're going to marry the Douglas fir?
He reminds me of home. He's big. He's cuddly.
Okay.
Look at those cones. Oh, he's such a sweetheart.
All right. But does he take care of you?
Absolutely he does.
Wow.
Maybe his canopy, his rain cover isn't great, but if he's, him and his if you go out with him and his buddies, he's going to take care of you.
All right. That's fair.
Make sure nobody fucks with you. Also, he's a hometown hero.
Okay. That's fair. It's fair.
So attractive to me that he's a hometown hero.
He's a traveler. You can go a lot of different places, whether you want to or not. You can go. Or whether they want him there or not, I should say.
Although his dad, who he's named after,
Yeah.
it's kind of a sad story. We don't like to talk about him too much.
That's fair. Okay.
So I'm definitely marrying Douglas fir.
Marrying Douglas fir. Okay, I need to say, if I was to choose any of these to marry, it would definitely be the Cowrie.
Okay.
Because I believe I would be essentially a god.
Yeah.
And I think that would be fun.
I think if you marry a god, you become at least a demigod.
Exactly. And on top of that, I can get citizenship in New Zealand. So
hey,
I'm in.
Dual citizen. All right.
So that's okay. So that's what I would marry the Cowrie.
Okay. I would say I would kiss the Cowrie.
Really?
I want that on an apron.
Yeah. Kiss me, I'm a Cowrie.
I think the Cowrie, just look at that stem.
Wow. Okay.
That's a thick boy.
All right, that's fair. That's what you'd kiss. Okay.
And it's also just this big, tall, thick, strong bear of a tree. I just feel like he would be a good lover.
And in case your matrimonially connected partner, Douglas fir, they would have that would be an equal fight, I think.
I think so.
I don't know who would win in that.
Hell, they may even get along. This is part of our whole arrangement, Casey.
I see. Okay. All right. Very fair.
And of course that leaves, I'm killing the thorn mimosa.
Yeah, well, you gotta kill something.
If the thorn mimosa were a person, it would be like this rat tail wearing, like thin mustache, but not shaved to be thin. It just grows that way.
Yeah.
Kind of oily person, pees in bottles because he's too lazy to walk to the bathroom.
That's horrifying.
That kind of guy. And I would rather he not exist.
Okay. All right.
And
that's fair.
I'm not kissing him and I'm not getting married to him.
All right. I see what you're saying. Well, I have to agree. I would also kill the thorn mimosa.
He lives off his grandmother's disability payments,
and doesn't help his grandmother.
No, of course not.
Yeah,
she waits on him hand and foot. She's like really old.
She thinks that she's doing him a favor.
Yeah.
When really
she's holding him back.
Mooching. All right. No. He's taking advantage of her.
Yes.
Okay.
That's essentially what I'm saying.
Well, I think that's fair, mostly because I don't want to kiss a tree that is so violent towards me.
Sure, yeah.
I certainly don't want to marry one because I don't like the desert. I like the desert just fine, but I prefer big forests of conifers.
It's fine to visit.
Some people just have their orientations. I'm a conifer person.
That's right.
I'm just a conifer person. It's the way it is. It's the way it's going to be.
You're allowed to have your tastes.
Thank you. Which means, of course, I would kiss the Douglas fir. So we just switched on that. I would only kiss the Douglas fir because I agree with that, but I kind of have this feeling that Douglas fir's kissed everybody.
Oh.
So I'm kind of like, yeah, okay, I'll join, but I want something a little more exclusive.
I see.
And that's why I'm choosing the Cowrie to marry.
Douglas fir is a little bit of a...
It's everywhere. You can find it down in Mexico at any point. You can find it up in BC and Canada at any point. You can find it running amok in other countries. It's something to be like, okay, you're a little bit too wild for me, even in your native land.
You look at his Instagram and it's like, wow, who are these other trees?
Yes,
it's
exactly.
Like this was from 2 months ago. We just started dating a month ago. Like, were you just dating someone right up until you got with me
that you didn't tell me about?
Yeah.
Like, I don't know, but I don't want to trash talk too much because I know you guys,
or betrothed, although now I'm having second thoughts.
Oh, sorry.
Yeah, there you go.
Yeah, we should play this game again, but with a different
set.
A different set.
I'd love it.
Mostly, if there is no conifers, I don't know what I'd do.
Well, that's a good idea for next time.
I'm
Create some drama.
Well, my mouth is dry.
Thank you so much, Rex, for your question. That was fun. Hey, if you've got a question for us or even a game suggestion, join up on Completely Arbortrary.
Tremium.
At arbortrarypod.supercast.com.
Right. You can also find it if you go to our Instagram, our website. It's all over the place.
That's
Basically,
right.
just look us up. You'll find it.
Google Completely Arbortrary Tremium, and you will find it.
That's exactly right.
Casey Clapp.
Alex, we've come to the end of another fine episode.
I like to think that we just rolled into Brie.
And where's Brie? Or are you saying we have been rolled into the cheese Brie?
Bree, the little holdfast, just east of Hobbiton. Casey.
Oh, Alex, that's
shoot.
like $5. That's not going to get us a very good thing. We maybe get like a 8-ounce latte around here.
Hey,
better than nothing.
Sounds good to me. So we have a couple more New Zealand trees coming up.
We got a few more,
and we promise not to say good day anymore. We will right after we finish recording, Casey.
You're going to delete it all.
I'm going to Google what is an appropriate, cool slang greeting in New Zealand, and we'll go with that.
All right, that sounds great to me.
Awesome. Thank you so much for listening to Completely Arbortrary. Hey, we'll see you next week. Goodbye.
See you later. Completely Arbortrary is produced by Alex Crowson and Casey Clapp.
Our artwork is by Jillian Barthold, and our music is by Aves and the Mini Vandals.
And you can support the podcast at patreon.com/arbitrarypod.
And find additional readings at completelyarbitrary.com. Thanks for listening.